So thank you very much for introduction, Max. I am very happy to be here, the last guy in that dev session. When I was thinking about the topic for this Pimcore Inspire, I found that there is something which is underestimated. That means those are the security headers. I would like to speak about it more in detail, but still this session is something called Dive In. I can show you the way. I can show you some hints from my experience, what to be careful about, what is important to do, but then, and you will like it as a developer, it's up to you to test it out yourself, find more information, and go ahead with that. It's quite important to start with why. And it highly depends. If you're a developer, then you would like to put in place cool things which will increase speed, security, and so on. If you are a client, then it's up to us, developers, just to explain to clients why they should need to have something like security headers and why they should care about the performance itself. So if can I generalize it into three main points, that it is that we care about security and performance. Security and performance from the perspective of server config and headers, it's quite interconnected. So if you put in place some security headers, it's affecting the performance and vice versa. You care about site reputation. So the users will be happy if they will say you are using something like HTTPS. If you are having some green badge, which is saying, okay, it's cool, it's fine. And also you care, and you should care about experience to the users. That means that the site is flexible, it's fast, it's loading the images in the correct sizes, it's loading them fast. And what are the challenges? What are the challenges right now? I can see three of them. The first one, those are the third-party services. Personally, I hate third-party services because it's decreasing. They are decreasing the security. They are decreasing the performance. You need to rely on them, and you need to live with them because there is no other way. You need to have something like Google Analytics, Google Tag Manager. Maybe the client would like to have something like Twitter, Facebook, YouTube. Try to name another services. And most of the web pages still is having at least one third-party service, which is most common, and those are the Google fonts. From the perspective of the years, I'm using something which is called Web Almanac. If you don't know that, just try to check it. They are releasing that almanac for 2021, but just some parts of that. So I'm having the data from 2020. And if we can look at the data which are in there, then the numbers in 2019 and 20, they are almost the same. It's around 94% of all the web pages from their sample, which is, I think, something around 1 million web pages, they are using third-party services. So you need to have it in mind when you put security headers in place, when you are optimizing the performance of the web pages. The second thing is that web pages are growing in size. If you look at that second diagram, it's quite shocking to me because 75% of the web pages are something less than or around 4 megabytes. It's quite a huge number. If you take into consideration that still in some countries, like Australia, even the US, the web access is in some areas quite poor. And mainly it's not about the data itself, but about the number of requests and also about the physics itself. Physics itself, it means that you cannot bend the laws of the physics. There is something like latency. You can increase the bandwidth. That's cool. You can do it. You can increase the technologies. There is something like 6G coming in like 4 years with the peer-to-peer communication. It will be super cool. But still, there's something like latency. Still, if you look at some poor guy, let me say in Australia, with some access to some wireless network, with some like 30 kilometers far away from some Wi-Fi, there still will be some latency. And I think that that's the biggest problem right now, not data itself, not bandwidth, but the latency. And we need, as the developers, to deal with that. I think the first thing is to compress the data. The other thing is to decrease the latency using some CDNs, and then also reduce the amount of requests which we are having. And the third thing, I think still very important, is there is plenty of bad guys which are trying to do the bad stuff. That means many of types of attacks, XSS, man-in-the-middle attack, some third-party script liability, and also some special type of attacks like Spectre. You can read about this then after you will have the access to the slides. What is the most important thing to me is HTTPS. And there are the three main reasons why you should use HTTPS. Those sites which are using HTTPS are more trustworthy to users. That means that the user sees HTTPS and some badge, then he is more cool about the web page. It's about the security with exchanging the information, passwords, etc. And also HTTPS is saying, well, there's some certificate, you can trust it because it was issued by some certificate authority. Well, we can see here another picture from Web Almanac. We can see how many percents of the web pages are using HTTPS nowadays. That means that in 2020, it was around 75% for desktop and mobile as well. It's quite a cool number, but still I will be much more happier if it will be higher. And here comes the first header, which comes together with the HTTPS. And it's a strict transport security header. It's quite common header, which increases the speed of the web page itself. Why it's happening? It's happening because in most cases, if you do not have that header, the user is typing in the domain, the address, striking enter, is redirect, the HTTP web page is shown. Then there is some redirect to HTTPS. So it's doing the two requests to the web page. With the strict transport security, you have only one request then after it is remembered. How it is working? It is working like that. After user is redirected, he is receiving something like that strict transport security header, which is saying that there is some max age, which is specified in seconds. There is some another option if there are included or not the subdomains. And there is something like preload, which I will cover later on. And it's saying that if the browser is receiving that kind of header, then it is remembering it and will never ever access the given web page with HTTP in that time frame of the max age, which is in that header. This eliminates possible man-in-the-middle attack, which can happen in that part of HTTP communication. But without the preload, user can still be vulnerable to the man-in-the-middle attack. So what is preload? It's something quite interesting, and I've noticed that it's not implemented correctly in a lot of web pages, which are just putting that preload into HSTS headers, but with not effect. There is a web page which is called hstspreload.org, when you can check your web page if it's okay or not. And it is generating something called preload list. Preload list is something which is integrated into the browser itself. And then browser automatically, if you put in some address, is checking if that address is in the list. And if it is in list, it is directly making and doing the request to the HTTPS itself. So from the perspective of that preload, it is important that there's a huge list of the things you need to do before you submit your web page to that service. Is that you need to have certificate, you need to have the redirect from HTTP to HTTPS. You need, and it's important, to serve all the subdomains through the HTTPS. So you are specifying that you would like to include the subdomains. Be careful about this, because if you include subdomains to that kind of header, then you are saying that the browser will access directly HTTPS for all of your subdomains. It's very dangerous if you do not know what you are doing. Then you need to meet few points. The first point is about the max age. You need to have in place max age of 1 year. Then you need to include subdomains. And then you for sure need to specify the preload directive in that kind of header. After all of those things are met, you can submit your domain into that list. It will be included in the list if everything is fine. And then you can use the preload itself. What are the recommendations for HSTS? It is the must for HTTPS. With something like Let's Encrypt, it's in most cases included automatically. Be very careful about the max age, because max age is quite tricky. It's better to start small with 1 day, 2 days, 3 days, and be careful when you put something like 1 year, because if you put something like 1 year in there, then browser will remember it for 1 year, and there is no way back. You cannot undo that action. And consider the submission to preload list. It's a little bit more difficult, but it's worth of that. This is one service which is, I think, commonly used when you would like to check your certificate. There is Qualsys SSL Labs, where you can just put the name of your web page. I put there the pimcore.com, and it can tell you some insights about the certificate itself, some TLS and other things. It might be good to see if everything is fine in there. Everything what I mentioned regarding the certificates, it's based on that certificate authority trust. So it's based on the agency which is issuing the certificate, like Let's Encrypt or Qualsys or Komodo. But what happens if you cannot trust them? And it's 9 years ago, and there were some serious things which were happening. There was one thing where some CA was able to make 500 fake certificates. It's crazy. There was another issue with US-based certificate authority, and those guys, they just released some root certificate to one guy. And with the root certificate, you are almost able to generate any HTTPS certificate for any web page on the internet. So right now in 2012, the guys from Google came and told, well, enough is enough. We would like to do something about this. So they made something like certificate transparency, which is the ecosystem which is consistent of three major parts. The first part is logs. So it's some Google database with hash trees. It's from the days where there was nothing like blockchain. So they developed their own append-only database, put it into that log systems where all the new certificates were put. And then it was easy to validate if the certificate is valid, expired, it was created, and it is okay. Another thing are the guys which are called monitors, is like organizations like Google, Facebook, which are just analyzing that kind of logs and looking for some suspicious activity. That means that they are trying to find out of those millions and millions of certificates, there's something wrong in there. And there's the most important part in there. Those are the user agents. And the user agents are just performing that auditing. That means that if they are accessing the web pages, they are checking against the logs if everything is fine. If not, they are just letting know the authorities that something went wrong. I hope it's big enough. This is something which is showing the issue certificates for pimcore.com. So you can see all the certificates which were issued for pimcore.com. You can also see that there's a number of the issued certificates. You can open then all the certificates which were issued for pimcore.com from the Let's Encrypt authority. Also, you can see the column which is showing in how many CT logs that entry appears. This thing is cool, but on the other hand, it's possible to any bad guy, let me say attacker, to find out any certificate which was issued for pimcore.com or any other web page. So if you are having some web page, subdomain, which is, let me say, secret, and you do not have it under some authentication or some IP address whitelisting, then it can be easily found out in registry like this. Another header is connected with those things, and it's expect CT. That header is quite interesting and quite old. And if it's there, it's specifying the max age. It's specifying the mode. You can specify the enforce mode, and you can specify the report URL. What it is doing? It's doing that if this is in place, the browser is storing internally that it will check the certificate for given page for given amount of seconds maximum. And if something is wrong, then it will contact that report URL. For those report URLs, you can have your own endpoint, or you can use some mostly paid services to handle it for you. It's quite cool feature because it can tell you that something strange is happening on with your certificate. Also will tell you that the certificate expired, or there's some problem with the TLS, and so on. The support here is in Edge, it's Chrome, Opera, you can see Chrome for Android, also Samsung Internet. It's quite common header, but it's deprecated right now from the June of 2021. So if you are using it, it's good just to remove it, unless you would like to have some backward compatibility, let me say with some old Internet Explorer or some older browsers. The situation right now is that we say goodbye to expect CS, and there is something which is called SCT. It's quite interesting. It's, let me say, framework or technique which is called signed certificate timestamps, which is helping the browser a lot, because it can be sent by the extension during a TLS phase of the connection, or it can be the part of the certificate. What it is saying? It's saying that if you visit the web page, then you obtain the information that there is some signature, there are some information about the certificate, there is the issue date, and there's the most important part, and it is that is the part with log ID, which is saying, well, browser, you can check the validity of the certificate here, and you are able to access the log and see, yeah, it's fine, and the browser can just proceed to the page itself. So recommendations here. You do not need to care about this, because Let's Encrypt is supporting it from 2018. Certificates which are not having SCT are marked as invalid by the user agent. For you, it's good to check if SCT is in place for your certificates, but mostly it will be there for almost all the certificates which are issued recently. So this is the part of HTTPS which is finished. Let's jump to another headers. This one is very, very old. The X content type options, that's the header which was originally introduced in Internet Explorer 8. So it's years and years ago. And it was the kind of the header which was very good, because it is blocking the possibility of executing some JavaScript files. That means that there is only one option, no sniff. And if you put it in place, then if you are having some style tag or script tag, which is having some URL, it is checking if the MIME type is correct. So it's not allowing the possibility that, let me say, in CSS tag, there is some URL which is returning JavaScript included. So in other words, there is no possibility to execute some JavaScript files in that kind of way. The browser will block it by default then, and also will block it for third parties. That means that there is something like corp, this cross origin read blocking. So it's protecting you also for some external resources you are loading. So it's quite cool. Still, there is a possibility of XSS attack, but it's much, much, much more secured. But you need to be very careful about the third party if they are returning the good MIME type. And also you need to be careful about the MIME type or of the resources you are returning on your web page. So it's about the good configuration of the web server. And you will find it out very easily if something is wrong, if you have that header in place. and mime type is not working correctly, then after you will visit your web page, it will directly download the HTML file instead of loading the web page. So it's quite easy just to find out that something is wrong in there. So here it's quite good header, but you need to be very careful, especially about third parties, if everything is fine in there. Another most and quite common header is the referrer policy. And with referrers itself, it's, well, quite dangerous. Because by default, referrers are sent almost everywhere. So if you click the external link, that external web page is seeing the referrer. So it's seeing the full address without the get parameters. Also, those third-party services, they are able to see those referrers in their audit logs, so access logs. So it's quite dangerous in the situations where you are having some, let me say, publicly accessible private links. That means there's your domain, some special hash, and is only known to some amount of persons. Those may be exposed to third party, to another services. It's quite dangerous, and especially it's dangerous because those referrers are also exposed to iframes and other resources like JavaScript, CSS, even fonts. Well, so what to do about this is that there is a plenty of possibilities what you can set into this header. In most cases, you will see something like this. There's some simulation of the request. I was just reaching our web page kurzor.net. I just clicked the badge of the Pimcore partner we are having in the footer, and I was redirected into pimcore.com onto the section of our of solution partners onto our Kurzor detail web page. So Pimcore itself, their server is seeing the referrer here, like Kurzor.net. There's only origin, and it's able to see it in some Google Analytics logs or any other services which are working with the referrers. What I recommend here is that for the most of web pages, there's good to have in place something like no referrer when downgrade. Then means that the full referrer will be sent only if it's still HTTPS. So for the most of the web pages, it's still okay. If you are a little bit more paranoid, then you can have another options, which will send the referrer across your domain or subdomain, but when it is redirecting or accessing some external resources, it's only sharing the origin. Origin means it's sharing that subdomain or domain. I think it's okay for most of the cases to have something like this in the place. I think the best one is strict origin when cross origin. So it can help you a lot, and still it will not break any other services. Because there are some services like Vimeo or another which are checking the referrer. On Vimeo, you are able just to say, okay, I would like to have that video only be possible to embed on some domains or subdomains. And if you are having that referrer policy set improperly, then it's not sending the referrer, and this thing is not working. So be careful about that. A lot of services, those are working with referrer, and still you can expose only your domain or subdomain. I think that for most cases, it's okay for you. Another thing which is not much common right now, those are the iframes. And for most of the web pages, you do not need to put your web page into the iframe, even within the same web page. So you can specify something like xframe options, and you can put there deny. I think it's for most of the cases. You're just saying, okay, I do not want to use that site in iframe in any case. Or you can specify same origin, so the iframe is possible within your domain or subdomain. Or you can whitelist some domains or subdomains by allow from. It's good if you know that some web page is just embedding your iframe, then you will just put the information into that header, and the browser will just react accordingly. It is good to put that header in place because there are possibilities for some nasty things like clickjacking, where some possible attacker can include your web page into iframe and then is able to do some nasty things with that. Most complex thing and quite complicated. It is content security policy. And I will show you that it can get quite crazy with some services. This is the header, which here there's that option to have that header report only. That means that you can put that policy in place just for testing. That means that it will be not actually blocking any things, but in case there's some problem, violation, it will report you to some report URL where you can just have your own endpoint, or still you can use some external service where you just then can analyze it and so on. Be very careful with that kind of the header, because CSP is quite dangerous if you are doing something you don't know what you are doing. The primary goal is to eliminate some kind of the attacks like XSS, to eliminate some possibility of loading some images, scripts, iframes from some not known or not allowed sources. So this is dealing with some external third parties. Also, it can restrict possibility where you can send some forms. So if some malicious software will change the target of the form, you specify only the targets which are allowed. So it's not possible to send some form to some external URL with good policy in place. And also you can deal with the blocks of some inline styles and inline scripts by allowing them, checking some hashes, and so on. Here it's up to you to decide if it is something which is needed for your site, because according to statistics I have, and I was able to find from something around 100 million web pages, only 4.32% is using content security policy. There are some reasons for that, mainly because it's quite complex and complicated to set up. If you are using the third-party services, and some web pages are using plenty of them, it can really get very complex, complicated, and hard to maintain. I included here some example of one service. It's SmartLook. That's the service to record the visitors. It's something similar to Hotjar. And even for that service, it's quite complex here, because you need to allow the source of the scripts, some things for the WebSockets, some things for that script tags within your footer as well. And even here, for one service, it's quite complicated. try to add another services like Google Tag Managers, Google Analytics, Facebook, Twitter, Facebook, and so on, and you will have something which will be very, very huge. And think about the situation that those things are changing from time to time, and you may break it a lot. There's another thing which is a little bit less common. You are able to use something like feature policy, where you can just allow or disallow some browser features. So you can say, whoa, never ever use geolocation on my site, or never ever ask camera on my site. This may reduce the risk of some malicious JavaScripts, which will be accessing some JavaScript APIs. There are plenty of other things you can just control, some autoplay, some full screens on the iframes. As I said, you can control if the camera and microphone can be used on the web page. Also, it's possible to have information and control some sizes of the images, some compression of the images. You can read about this more. There's a source on developersgoogle.com. It's quite good reading. It's quite easy to put it into place. Here it is how it is supported. So you can see Edge, Chrome, Opera, and so on. But have in mind that that thing is deprecated right now. So you need to use something like permission policy or document policy right now. And you can still use it in case that you would like to have some backward compatibility. But it's only a matter of time when the support for that header will be just dropped. So the new headers are permission policy and document policy. You can read about it more. There's a link for document policy. With the permission policy, well, it's almost the same like the previous header, just the notation is a little bit different. It's good to put it into place. Possibly you will not break anything, but it's quite more tricky if you are using some of those things on your site, some of those features. Here is support, so you can see Edge, Chrome, but there is some partial support for that. So it's still evolving, but right now you can see that it's globally supported, but something around 60, almost 7% of all the users. Well, another headers you should be careful about. Those are the headers which are exposing something, which can be used by some bad guy, hacker. It is not a good idea to expose some versions. That means that you expose here like Apache / some version and operating system which is using. Also, sometimes it's not good to expose even the system itself. It happened to me in the past from some clients that they wanted me to remove even that powered by header from the response headers. Still, I think that like finding out if the site is using Pimcore, it can be done from the other sources, different than the headers itself. But still, be careful about those headers, where and how you are using them. And here it's, I think, quite important thing, and there is reporting. I mentioned a few of the headers like CSP, expect CT, which are having the possibility to use for using some endpoints for reporting. There is also the possibility to have something like report to, which is enabling the reporting API. So you can then put there some information from that CSP and so on, and put it into some service like, I don't know, Cloudflare is having it by default, or you can configure it in there, or you can connect it with some external services. Quite important thing is something called NEL. That's the that's the header which is specifying the endpoint for any kind of network or application errors. You can connect it with external service, and especially for some applications which are having some offline mode, or applications which are working on mobile phones where sometimes there is no network connection, or you would like to see if DNS is working, or if some sockets are working, or if some other things connected to network are okay. It is fine to put that header in place, connect it with the reporting tool, and then you are able to see such of information from the users, even the information about the expired certificate and so on. And there are plenty of headers which are coming all the time. So I noticed that there are 3 additional headers which are in there right now. There is also recommendation, and I've seen that header quite often. It's that XSS protection, which is quite old header, and it's deprecated, and it's not working anymore in most of the browsers. Chrome was having some plugin for that, which was removed in version 78. So if you are using that header, it is good just to remove it. And right now there's the demo time. There's very good service which allows you to check your web page and check your security headers. It's quite easy. You just put your web page domain there and just strike scan. And in that demo, I will just show you how it looked like for pimcore.com. And I would like to then, after this presentation, consult with the guys from the Pimcore, because there are some things which I think at least maybe they're having some reasons, maybe not. I put it in there. I can see the B score. B score is not bad. It's quite okay. It's saying that strict transport security is in there. Type options, that's cool. X-frame options. Referral policy is in place. Content security policy is missing. Yeah, there are some significant reasons. I've seen that there are plenty of third-party things, so it would be crazy to put it in place. And permission policy is missing, I think, because there is not any usage of video, audio, microphones, or any other geo information and so on. So if I look onto the report, the service is showing that raw response headers. So imported parser there, you can see the server. So it's showing Apache. It's cool without any information. That's fine. It's showing, yeah, pimcore.com is surprisingly working on Pimcore. You can see another interesting thing. It's showing that the strict transport security header is sent twice. It's happening sometimes when you are using some load balancer or reverse proxy or even Cloudflare. So here the data and max age is the same, so it should not cause any problems, but it will be cool just to investigate it and see what's going on. With the content type options, no sniff, it's cool, that's fine. With the X-frame options, it's saying same origin. That means that it allows Pimcore to embed iframe with Pimcore within the same site. So maybe there are some reasons for that. I wasn't able to find out, but maybe yes. If not, it's much more better just to put there deny. With referral policy, there was something I was not able to see if there's intended or not. But what the referral policy is saying here is that there's the option same origin. So it means to the browser that the origin is sent only across the pimcore.com. But try to imagine the situation. There is some detailed page of the partner. You click the button there, which is redirecting you to partner web page. This will just come into the thing that the referrer will not be sent there. It's quite, I don't know, intended or not, hard to say, but in that case, that partner will not be able to see in Google Analytics that that click was through the pimcore.com. With the XSS protection, I think that this header is not needed anymore, but still, for some backward compatibility, why not to just keep it in place? There's another thing I just mentioned. There's that content security policy. This is something which is up to developers just to decide if it makes sense or not, if it's too complex, too complicated or not. With permission policy, my opinion is if you're not using any that JavaScript and browser APIs, it's fine to don't have it in there. And there is the warning which is saying that strict transport security is there twice. And there is the most important thing. You can see that there is a preload option in there. And if you remember my past slide, to preload to have effect, you need to submit your web page to the preload list, which is that does not happen for the pimcore.com. And also, even if it will be in that preload list, there needs to be specified that strict transport security needs to be enabled for all the subdomains. So this thing is in there, but the preload option will not be working. So that's it. It's just fine if you will try your own web pages, how it will look like. The conclusion and recommendation is that you need to be careful about CSP, HSTS, referral policy, because it's quite dangerous. Try to have detection mode first, because you can break a lot of things. If you have detection, you will just be notified. It's good to set up reporting, and you can integrate the headers in the order as they appear in that presentation. And have in mind that even from that service which I've shown you, the A+ grade is cool, but the question is if you need it.